is the characteristics of the database approach. So now before going to the characteristics, we'll have a look into the sample database, how it look like for a university. So here university database includes the different entities like students, courses, sections, department and instructors. So these are the different entities through which where we are going to maintain the database. And also here we are going to give a relationship between each of these entities. So that is mentioned here. That is students sections or specific courses. Students take sections. Courses have prerequisite courses. Instructors teaches sections. Courses are offered by the departments. The student major in departments. So these are like how we are going to give the relationship between the entities. And this is a sample database, how the data is stored for a student, where we have a set of attributes that is nothing but fact about the entities, name, student number, class, major. So where we have two instances of the record. Similarly, we have records for courses, then followed by section, then grade report, prerequisite. So now to take that particular course, what are the course the student should be knowing? So that is mentioned here. Course number and what is for this course, this is a prerequisite course number. So now we'll discuss about the important characteristics of the database approach. So where we are going to compare this with the file processing, the traditional file processing and DBMS or database. The traditional file processing, each user define and implements files needed for a specific software application. For example, one user, the grade report office may keep files on student and their grades. The second user, that is accounting office, may keep track of student fees and their payments. Although both users have interested in data about the student, each user maintains separate file and programs to maintain these files. So this what happens at some point of time, it leads to redundancy. Defining and storing data results into the same data results into wastage of storage and redundant information. So whenever if the data is redundant, the consistency may not be ensured at some point of time. In database approach, a single repository maintain data in a defined a single repository maintain data that is defined once and accessed by various users. So once it is created, it can be accessed by multiple users. It does not require to keep the same data in multiple places. In file system, each application is free to name data elements independently. In database, name or label of data are defined once and used repeatedly by queries, transactions, and applications. So now we'll go in detail about each of these characteristics. The first one is self-describing nature of the database system, isolation between programs and data abstraction, support multiple view of data, sharing data, and multi-user transaction processing. Self-describing nature of a database. The database system contains a complete definition of database structure constraints. So where it is going to define what are the attributes. So what are the conditions on those attributes is clearly specified. This definition is stored in the DBMS catalog, which contains information such as structure of each file, type, storage format of each data item, and various constraints on the data. The information is stored in the catalog is called as metadata. It describes the structure of primary database. Metadata describes the structure of primary database. In case of traditional file system, what happens is the data definition is typically part of application program. Hence, these programs are constrained to work only on specific database whose structure is declared in the application program. For example, application program written in C++ may have struct or class declaration. So it is going to give constraint where we have to use the same structure. If the structure is different, we cannot access the data. So it is very specific to that particular application program. The second one is insulation between programs and data abstraction. So in case of traditional file processing, the structure of data file is embedded in the program, application program. So any changes to the structure of file may require changing all programs that access the file. In DBMS, the structure of data file is stored in DBMS catalog separately from access programs. This property is called as data independence. Then we have program operation independence. The user application program can operate on data by invoking operation through names, arguments, regardless of how operations are implemented. So here we are not going to bother about how it is implemented. Instead, we are going to just have a look into the operation to be performed by the that particular function. And it is not going to be specific to any data type. So it can work on any data. So this we call it as program operation independence. The characteristics that allows program data independence, program operation independence is called as data abstraction. So this is an example of catalogs or metadata where it describes the data about data, or the structure of the data, data type, and the constraint. So all this information it is stored in the form of catalog. Data abstraction where it hides the operation, as the detailed operation is going to be. Data model is used to hide storage details and present user with conceptual view of the database. So how the data is stored in the physical media, it is not going to be specified, but the conceptual view of database can be viewed by the user. The data model uses logical concepts such as objects, their properties, and relationships that may be easier for most of the user to understand than the computer storage concept. So understanding the computer storage, it is going to be difficult. So now it can be used at the conceptual level so that the user will be easy to understand. So the data model hides storage and implementation details that are not interested to most of the database users. Support multiple view of data. So in case of uh, traditional file approach, the single view of data, it supports only single view of data. Database typically has many users, each one requires different perspective or view of database. A view may be subset of a database. So DBMS supports, depending on the user requirement, it can create different views of the database. It's not necessarily only one view that how it is used in the traditional file system. So that is one of the important characteristics that is supported by the DBMS. Then we have sharing database and multi-user transaction processing. So multi-user DBMS allows multiple users to access the database at the same time. This is essential if data for multiple application is to be integrated and maintained in a single database. DBMS includes concurrency control software to ensure that several users trying to update the same data to do in controlled manner so that the result of the update is going to be correct. So this is all includes in the transaction processing applications. Then we have OLTP database, that is online transaction processing. It is in a type of transaction processing concept is a major part of database application. So allows hundreds concurrent transactions to be executed per